assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
This problem involves the example of a trapeze artist sitting on a swing and swinging back and forth with a period that is equal to 8.85 seconds. And then the person then stands up, which is going to cause the center of mass to raise up in this system by 35 centimeters. So we have an increase of 0.35 meters in our system when the performer stands up. And we're going to treat the performer in the trapeze as a simple pendulum. So before we can figure out the new period, we have to first figure out what is the original length before the performer stood up. So we're going to use the equation t equals 2 pi times the square root of L over G. And if we rearrange this in order to solve for L, so we would end up squaring everything, and then, so we would have t squared equals 4 pi squared times L over G. And then we would divide t squared divided by 4 pi squared equals L over G. And then finally multiply by G. So we would end up with t squared times G divided by 4 pi squared equals L. So we know our period. Our period we have is 8.85 seconds. So we have 8.85 squared times gravity, which is 9.8 meters per second squared, divided by 4 pi squared equals L. And that gives us an L of 19.44 meters. So now we have our length, our original length. Now we can go on to figure out what the new period is going to be after she stood up. So our new length, we'll put as length standing, equals our original length minus the 35 centimeters 0.35 meter change in the center of mass, which is going to equal 19.44 minus 0.35 gives us an answer of 19.09 meters. So that is the new length of our pendulum. So going back to our original equation, we're going to do period equals 2 pi times our 19.09 divided by gravity, 9.8, and we get that the new period equals 8.77 seconds.